recording. Okay, so let me go back to whiteboard and let us see what happens when the name node crashes in a typical configuration. Okay, so if you think about it, there are multiple scenarios where name node crashes. Okay, so it can be a memory issue, or it can be overload of resources, which is more trivial. So if there is overload of resources for some reason, if the name node crashes, it will bounce immediately. Or it can be replacing the hard disk, or it can be anything. So depending upon the issue, the magnitude will differ. Okay. In some cases, motherboard might gone down. In some cases, it's just replacing a hard disk or upgrading the name node, something like that. In case of scenarios where name node crashed, and if you can bring it up immediately by resolving the issue, you can just start it in the safe mode, and the FS image will be restored and the clock will be applied to get the name node to the current state, and it will be it can be fast. But let's talk about more significant issues like a hard disk failure or motherboard failure or something. Our cluster will look like this. Okay, so this is our name node. This is our secondary name node. Okay, and then there are a bunch of data nodes. And then there will be a network switch in between where your name node, secondary name node, and all your data nodes are connected to the switch. So this is how the structure will look like. Now let's say what happens if this name node is broken because of a motherboard issue. So one of the easiest ways you can think of it is getting your secondary name node as name node. But if you see our cosite.xml or if we go to the configuration, and we spoke about the most important parameter called fs.default. FS, right? So this one is configured for our name node. So even though here it is not showing up the actual IP address, when we actually see the configuration files from the servers, if I go to var1 cloudera fcm agent and process, this is where you will see the actual parameter files. As you put, and then let me go to this location, and this is where your parameter files will be. And here I am on gateway, so probably let me see this. Yeah, so if you look at cosite.xml here, it is pointing to our name node IP address, which is 502. Now, even if we can, even if we have to change the IP address, sorry, if we have to change the secondary name node status to name node, you have to still build a secondary name node to be helper of the new name node, or you have to get a new node to be a name node. In all these scenarios, you have to update the IP address of your parameter file on all the data nodes. Okay, because these configuration files have to be consistent on all the nodes in the cluster, and they will be there on all the nodes in the cluster, all the XML files. They have to be consistent, and they should have the name node IP address pointing to the right node. So you have to change all the parameter files, which is a tedious task in a very large cluster. And also even the restore and recovery. So when, let's say this node is down and you got a new node to make it as a name node, and you want to keep this yellow one still as a secondary name node. So you got a new node in place of this, and now you want to make it as a name node. So you have to get the FS image and the edit logs onto this. Start this as in safe mode so that FS image and edit logs are restored and recovered. And then you have to change the IP address and all the configuration files in the cluster. Even if you use Cloud Era Manager to do these tasks on a very large cluster, can take a few hours. If name node goes down, everything will come to standstill. Nothing will be working on that, and it is a major issue, especially on very large clusters. If the downtime is not acceptable for a few hours, then this whole process is not practical. So that's where they have come up with a concept called high availability, where instead of having a name node and secondary name node, you will have an active and passive. Okay, and to overcome the issue of changing IP address and all the things, there will be a logical name called namespace, so or name service. So that name service can be translated into both the IP addresses, whichever is active at the time, and also second thing is instead of checkpointing at regular intervals, this active and passive will be in sync as and when there is a change in name node metadata. So the whole process of updating metadata is changed so that the time to failover between if one name node goes down, the time to failover to second name node can happen as fast as possible. So what they have done is instead of doing checkpoints at regular intervals, they introduce a new process called journal nodes, and those will be configured using a coordination process called Zookeeper. So you will come across so many new terms just to enable high availability configuration to address the issue of changing IP addresses in case you have to bring a new name node, and also to reduce the time of restore and recovery. So we will see all those details and we will understand more. But theoretically, I hope you understand what we are trying to address using the high availability configuration. Even if you have questions, just bear with me. We will see, and then we can talk about that. In high availability, we will not have secondary name nodes. Instead, we will have an active and passive name nodes. And there will be journal nodes to push and apply edit logs in real time. So from active is the one which will be having the current snapshot of the name node, and these journal nodes will actually read that, and also it will maintain multiple copies of the edit logs in multiple locations, and all these things will happen in real time. And it uses Zookeeper to keep all the journal nodes in sync. So it is a coordination service. It is if you are from Oracle background, in Oracle we hear about the CRS, Cluster Registry Service, which will keep track of, which uses a concept called quorum. I will not get into all those details. Even Zookeeper uses a concept called quorum, and it is a coordination service like CRS. So it will take care of multiple journal nodes, keeping all the edit logs in sync. Okay, so this is how it will look like. There will be a name node, and there will be a quorum journal manager, and then there will be journal nodes, and these journal nodes will create multiple copies of edit logs in multiple local disks, and also it will be one of them will be passive as well. So even the passive name node will have the latest copy of the edit logs, and they will be applied in name node as and when it receives. And so the in-memory snapshot of your name node, active name node, and the passive name node will almost be in sync. That's how you will reduce the restore and recovery time. now we will see how to configure the HDFS name nodes using Cloudera Manager, and we will review the parameter files, and we will understand how it works. Okay, so let's go back to the cluster, and this is the most important button in Cloudera Manager. It lets you to add the service, to delete the service, to start the service, to start all the services in the cluster, etc. Okay, and let me see. Yeah, so we clicked on HDFS because it's related to HDFS. When you actually click on HDFS and click on instances, you will see a button called Enable High Availability. If you have to do it in manual process, it is pretty tedious. Without Cloudera Manager or Hortonworks, if you want to enable high availability, it is pretty tedious. Using these web interface tools, it will be pretty straightforward. And here, you can add role instances, like if you want to add more data nodes to the cluster, you can click on this and add more nodes to the cluster, data nodes to the cluster. And also we have spoken about edit logs, FS image, and checkpoint, right? So in case, by default, the checkpoint happens based upon the parameters which we have seen earlier. In case if you want to do it manually, you have to click on this button, and then it will roll the edit log, and it will start creating the edit log. And then the last copy of edit log will be merged with FS image by the secondary name node. So if you want to force the checkpoint, you can click on this. Even from command line, there are commands which can trigger that. But if you want to use Cloudera Manager, this is the place if you want to trigger the checkpoint in a typical configuration. Now this button will facilitate us to enable high availability. So you have to click on that, and it will ask for the name service. So name service is nothing but a logical thing which can resolve into whatever name, whatever IP address is active, is working as active name node. In this case, we will configure 2 and 3, 02 and 03, CDH5, 02 and 03 as active and passive as part of one name service. Earlier, 02 is name node and 03 is secondary name node. Now, as I mentioned in the previous slide, there will not be any secondary name node. We will have only active and passive. So we are transitioning the secondary name node into active or passive as part of the high availability configuration. Okay. And this is the name service. We will come to the IP addresses in a moment. You can give the name service whatever you want. I am just leaving the default one. And click on continue. And already picked up the current host. You can add other host for the passive configuration, and you can click on OK. So now you have 2 name nodes. Earlier there is only one. Now you have 2 name nodes. If you see, the service of name node is started on this as well. Earlier we have only on 502. Click on OK, and then we need to have journal nodes. Okay. In this case, I will use 504, 505, and 506 as the journal nodes. Okay, and those ones will create copy of the edit logs on multiple locations. The purpose of it is, even if one node goes down, the edit logs will be available on the other nodes, and those will be shipped to the passive node at the time, and the passive node will take care of applying that into the memory, so that the in-memory representation of active name node and passive name node is almost same. Okay, click on continue, and we automatically our Cloudera Manager will take care of starting the zookeeper. So we need not worry about most of these things, as we start on a clean slate. We don't have the zookeeper, so we are actually initializing as part of this. Okay, and then you can click on continue, and it picks up most of the parameters based upon the primary node. So it for name node directories, it picks up DFS and then on 503 as well. Before at this time when we have normal configuration, let me go to 503. And if I sudo su to root, and if this is a secondary name node currently, and if I do lslbr, I have only SNN. But after this, it will create a NN directory as well, because now it is a name node rather than a secondary name node. Yeah, HA does not replace name node. Okay, so in case secondary name node works as a helper to checkpoint at regular intervals, whereas high availability, you will have multiple name nodes. So we are not replacing the name node, we are using the same name node which is there earlier as well. Now we are replacing the secondary name node into a passive name node. Okay. And you can hit on continue. Okay, it is complaining that journal edit directory of role on novisync cannot be empty. Let me see. So I have to give the path. DSS, let me say JN. DSS JN. Now click on continue. Okay, so I need to configure Zookeeper upfront. So let me close it. So to enable the high availability, I have to configure the Zookeeper. I thought it will pick it up. So for that, you can click on this and click on add a service, and you can start the Zookeeper. And I would like to start the Zookeeper on 5. Actually, Zookeeper also requires 3 nodes. So I am starting on 502, 503, and 504. Or let me start on 504, 505, and 506. Okay. And hit continue. It's a coordination service. So we have to have at least 3 nodes for Zookeeper. And hit continue. Yeah, I'm getting a call. Let me take this. So I'm back. Can you hear me? Hello, can you hear me? So we have started Zookeeper. Hit continue, click finish. It is pretty straightforward. And let me see. Yeah, canary, no need to worry much. It will be sorted out by itself. And then now we will hit on HDFS. And we will go to instances. We will start the high availability. Click on continue. And we will use 503 as another name node. And general nodes I will use 4, 5, and 6. Okay. And hit continue. So directory is DFS JN. Hit continue. But unable to find a Zookeeper is a coordinator service. So whenever you have to enable high availability or load balancers, It's typical that you need to have a coordinator service, and Zookeeper is a coordinator service for big data type of tools, whether it is Hadoop or Cassandra or anything. You typically use Zookeeper for the coordinator service. Unable to find a Zookeeper. I don't think so. Let me see. I think I know the issue. Let me sort it out. Yeah, probably I need to have Zookeeper service must have an odd number of servers. If I have the odd number of servers, let me click on this. Yeah, 505. Okay, it has 4. Okay, let me go to instances and remove 500. So I'm restarting it. Probably you are right, Chintan. I need to have it on 2 and 3. Let's see. It will not take long time. Force initialize the Zookeeper znode for autofail over any previous znode user. Yeah. Let me try. Zookeeper instances. Add more instances. Let me make them 5. 2 and 3 also. Okay, just have to start here. Starting the new Zookeeper servers may cause the existing try again after restarting any existing. Okay. Restart. Yeah. Okay. Close. HDFS and instances. Enable high availability. Name service 1. 503. General nodes are let's configure 2, 3, 4, 5, 6. Continue. What? Unable to find a zookeeper service in cluster 1. There is a service. Retry. No. It is calling the issue. Running. I will try once more, and if I could not resolve the issue, I will demonstrate on Sunday's class. We'll move forward. Okay. No, it is not working. So I will troubleshoot the issue. I ran it in the earlier version. Probably it could be the version issue. I will look into it later. We will proceed further, and we'll come back to this. So this is, if we pass on this, it is pretty straightforward. We just need to review the parameters, and the parameters will change a little bit. So you will start seeing name service 1 as part of the ss.default ss, and also you will see some additional parameters which we need to review. I will showcase on Sunday's class. Okay. Now let us move forward. So as part of the exercise, you need to understand all those things for day-to-day operations. Just give me a minute, okay? You need to know the commands to stop and start HDFS daemons. You should know how to copy data back and forth to HDFS. You should understand the parameter files and data files, both from Cloudera Manager perspective as well as the location on each and every node in the cluster. You should know how to restore and recovery of the name nodes. Typically, you need not do much. You just start and it will start in safe mode, and then you will be able to access data in name nodes. And all the important parameters and the defaults. And also you should be, this is very important, you should be familiar with the name node web user interface. Okay, and these are the interview questions. you should know the different HDFS and MapReduce demos. MapReduce we have not covered yet. We will see that going forward. How data can be copied in and out of HDFS. What is name node web user interface and what is default port number, and how do you restore and recover name node. What happens when name node goes down. So when name node goes down, everything comes to halt. Nothing can be done on the cluster. Okay, and restore and recovery, you just have to start the name node, and by default it will start in the safe mode. You just have to have your SS image and edit log in appropriate location, which is controlled with the name node named parameter. And as if you have SS image and edit logs in the appropriate location, when it starts the name node in safe mode, it will try to apply those things and it will try to start the cluster. And what is name node high availability or active passive configuration? What is the fault tolerance and how it is taken care with respect to HDFS? The answer is replication factor. And also what is heartbeat? So heartbeat is the mechanism how data nodes will communicate. Heartbeat is the mechanism used by data nodes to tell name node that they are live and up and running. If name node do not hear heartbeat from the data nodes for a given interval of time, it will discard from the cluster, and name node will not use that data node until it gets the heartbeat to store any data. So heartbeat is a very important thing, and it not only data nodes not only heartbeat name node to tell that they are live, but also they pass on information like how much capacity they have and how much is already occupied, so that name node can judge on what data nodes the new incoming data should be copied. Okay, on top of that, there can be other questions also like balancer and all those things. So I will try to add more and more questions to this. But these are the more common questions in interviews with respect to HDFS. Okay, now we are getting into MapReduce. Let me stop this recording and start a new one, because MapReduce is different topic when it comes to core components. So far we have spoken about HDFS, now which is storage. Now we are getting into MapReduce, which is processing.